Hi, Science 10. We are starting our video lessons. This is lesson 1 in chapter 3. Please turn to page 12. This is a lesson on balancing chemical equations. Please follow along on page 12 in your notes. We're looking at the parts of the chemical equations and how we can see that reactions can be in a sentence form, as you can see here. We can then take that and write down the words in that reaction. We can also write down the formulas in that reaction, but our focus right now is going to be how to balance that reaction to make sure that the number of atoms are the same on both sides of the equation, on the left side of the arrow and on the right side of the arrow. I wanted to review the word coefficient because that's the number that you can write in front of each compound in the reaction. The formula of that element you cannot change. If the formula is correct, you must leave the formula as it is. So as we try to balance on the two sides of the reaction, I'd like to just look at some hints here. It says when you write the reaction, make sure that your formula is correct. So this means going back to the practice quiz that I had posted, make sure that, or you can go through previous notes, but make sure that you have reviewed and are solid on writing correct formulas so that you can do the balancing properly. It does say that if you have some polyatomic ion, make sure that you take a look at those first and keep them in there as a whole and balance them. And you can balance anything that's like an element like H2 or O2 last, because it'll be easy to balance those last. So let's give that a try by looking at page 14 and going to your page 14 in your notes. I would like to have a look at this exercise. I think we had finished, but it's just a couple that I'll point out in terms of making sure that the elements on the two sides of your equation are the same. And in looking at something like number 3, where we see that there's one carbon on each side, that looks good. We look at hydrogen, there's 4 of them here and 4 of them here, because we count 2 times 2 to make 4 hydrogens, so that looks good. In terms of oxygen, 2 times 2 makes 4 oxygen here. We have 2 oxygen on this side, 2 oxygens here, so your oxygens are also the same. So on both sides of the arrow, we're looking at how the amount of atoms of each element are identical on both sides, and that means that our formula is chemical equation is balanced. And when we work on these, remember that if your formulas are correct, remember the letter T, things like H2, Cl2, those I2, those, if you make sure your formula is correct, then you can, of the individual parts of that equation, then balancing will always work out. In this case, chlorine is a C2, and so here to balance that, we have to put a coefficient in front so that this means 2 chlorines, but it also means 2 hydrogen. But we go back here and we already have 2 hydrogen. So we know that that is balanced correctly. Let's move on to the bottom of page 15, where we have the KI demo that was showing you like a formula for KI that was going to react if you added electricity, and what this was going to make was actually iodine in it was going to be in a glass petri dish. Unfortunately, I can't show you this, but it's a really great way to review the parts of the equation. So I'd like to look at this on the bottom of page 15 for just a minute, and we can see that looking at iodine as the product, there are two iodines here. So in order for us to indicate two iodines on this side, we have to write in this coefficient. So the iodine is now balanced, but this also means that there are two potassiums. So I go over here and say I need to balance by putting two potassiums here. Now my potassiums are balanced as well. This is just a simple start to how balancing will be done. The word coefficient is the number that you've put in front to balance your equation. The state are those that you can put into the boxes below or beside your elements or compounds. For some of these, we can find out, for example, that Ki is aqueous by looking at our solubility chart. Sometimes it's just something that is indicated or mentioned in your description of this chemical equation. So sometimes you just have to read and it'll tell you what those states will be. Reactants, that would be everything on the left side of an equation, and products would be everything on the right side of an equation. It's what is produced. Subscripts are things like the 2 that is next to iodine. That would be a subscript. A chemical formula would be a formula of this, like this element or this compound. That is a formula, whereas equation is the entire equation that you write about the reaction. The molecular model would be where you might write a model of something like Ki and see how it's bonded together, and how if you have two Ks, it would look like this. If you have, pardon me, we had two Ki's on this side of the formula. Two Ks and an iodine would look like this. So when you count it all up, when you look at what the model would look like, it would all equal on the two sides of our formula. I'd like to move on to page 17 in your notes and just take a quick look at a few of these. This is where we left off, and I just wanted to, I did post the answers for this, but I just wanted to talk through a couple of these that, for example, are correct, like number 7, where we see that there's 2 irons on this side and 2 irons of this side, so our irons are balanced. We have an O2 on this side, and this 2 also means we have 2 O's on this side, so that one is balanced, so that's why that was a yes. Comparing that to the one below, we have 4 times 5, which is 20 phosphorus, and on this side we have 2 phosphorus. So I can tell already that this is not balanced. Here we have 2 times 2, 4 oxygens. Here I have 5 oxygens. That's why number 8 was a no. So we're just in this exercise determining whether these equations are actually balanced. One more that we can look at here for 2 times 2, number 6 I'll look at. 2 times 4 is 8 sulfurs, and we have 8 sulfurs here. 4 times 3 is 12 hydrogen, and Here we have 2 times 6, 12 hydrogen, so that seems like it's balanced as well. This one, 2 times 11 is 22 oxygens, and so you have to count oxygens in 2 locations. So looking at the oxygens, I see 2 times 8 is 16 oxygens here, plus another 6 oxygens here, and we in fact do get 22, which is what we're seeing on this side. So this is number 6, another example of a balanced chemical equation. I'd like to go to some practice with you, and the practice I'm going to do is not a page that you have, but you can certainly follow along as I'm showing you how I would think through the balancing, so that you can all do some practice in your notes that I will be assigning before our lesson 2 tomorrow, which is looking at the different kinds of chemical equations. Today, I just would like you to practice doing some balancing. So follow along with me. You do not have this, although you could perhaps stop the video and take down some of these before we practice, or just listen as I walk through them, and then I'll assign some practice that you can do from your notes. So number 1, when I look at this, I immediately go to the nitrogen and say I have 2 nitrogens on the left side. Remember, we're balancing on the 2 sides of the equation, so take a look at where your arrow is. On the right side, we only have 1 nitrogen. The only thing I can add in is coefficients. You would never change any parts of the actual equation of any, or formulas of any of these compounds. You are only able to put in coefficients. So in this case, when I have the 2 nitrogens on both sides, I check them off. I now check what this 2 has done to the rest of the formula. 2 times 2 hydrogens means we have 4 hydrogens. So if I go to the left side, I realize there's only 2 hydrogens, so the easy thing to do is put a 2 for a coefficient, and now this means 4 hydrogens, 2 times 2, and this also means 2 times 2, 4 hydrogens, so our hydrogens are also balanced. So our equation is now balanced. Moving on to number 2, I have 1 sodium, 1 sodium. I have 2 chlorines on the left, only 1 chlorine on the right. That means I have to write down a coefficient of 2. So now the 2 chlorines are balanced, but the 2 sodiums are not. So I have to go to the left and balance my sodiums with a coefficient, and I check off that they are now equal on both sides. Number 3, when I look at water here, I can see that there's only 1 oxygen right off the start. So to balance the oxygens, I know I need to put a coefficient of 2. That means 2 oxygens, which balances them, but it also means 2 times 2, 4 hydrogens. So I go to the right of this chemical equation, and I need to put a 2 here to make 4 hydrogens on this side as well. When you see that the left and the right side are balanced, you know that you've finished balancing that equation. Number 4, for this one, I have a hint. If you see OH over here, that is a polyatomic ion, but you don't see an OH on the left side. So what you want to do with water is always write it down as HOH. That way you can balance your OHs, and it will make it much simpler to work with equations when you write down water as HOH. So in this case, I see that I have 1 OH on both sides. I see that then this means that there's just the H over on the left, but I have a 2H on the right. So I will say that we need to put 2H2, which makes 4 hydrogens. Here, I would like to see 4 hydrogens as well. So I'm going to put 4 hydrogens here. So that'll be 4 hydrogens, but that also means 4 OHs, which I think I messed up. So pardon me, everybody. Let's start that one from scratch. This is why live video can be dicey. Okay, well, let's go and try that one again. So if we, good thing I have the eraser function, and that's why you have erasers too. Okay, so if we go with 2 OHs here, that's going to make more sense. 2 H's here, 2, remember we don't need to look at this, we can just look at HOH here. 2 H's, and that balances our hydrogens. Now this also means we have 2 OHs, which on the right side of our equation means we need to put a 2 here. So this will now mean that 2 OHs or hydroxides are balanced. It also means that we now have 2 sodiums. So I scoot to the left side and need to put 2 sodiums. That, my friends, is the correct balanced equation for number 4. Alrighty, let's go to number 5. And for this one, I often would look at what we have multiples of, like chlorine on the right side here. So because it's 2 chlorines, I will go to the left and say I need a coefficient of 2 to balance our chlorines. That means there's 2 hydrogens, but I see I already have 2 hydrogens. I check out my zincs, they are fine, we are done. I'm going to skip the hydrocarbons for today because I'd like to work on that after you've got the hang of the other types of equations, because there is a special rule for balancing hydrocarbons. So I'm going to move on to having you follow me through maybe a few more here, going to number 8. We have chlorine, 2 chlorines on the left of our equation. So to have 2 chlorines on the right, I would put a 2 balancing our chlorines. However, this also makes it 2 sodiums. So I go to the left and put sodiums, and I notice our cobalts are already balanced, so we are done with that one. Maybe we'll walk through one more here to wrap up our video for today, and that would be number 9. I'm looking at how to keep your polyatomic ions together. So on this side, I see I have 2 phosphates. And so on this side, so you can see it clearly, I realize I just have one of them. So in order to balance that, I will have to put a 2 here and keep it together. That means we have 2 phosphates. And on the right, I look at that and say I already have 2 phosphates. So my phosphates are good. But over here, that also meant when you write in that coefficient, it means we have 2 times 3, 6 sodiums. So I go to the right and I say, now I have to make sure to add 6 sodiums. When you do that, it means I now have 6 chlorides as well. So I have to go over here and say, how do I make this side 6 chlorides? It would mean 2 times 3, because now this would also be 6 chlorides. This is where you can check off your chlorides and say, I see this also means I have 3 magnesiums, and I go to the right and see that I already have 3 magnesiums. So having done that and checked off all of my parts of the equation to make sure they're equal on both sides, this is now a balanced equation. I will maybe scoot down to looking at something like number 11, where if I have 2 NO2s on the left and I have 3 NO2s on the right, I have to make sure that they both then are multiplied by something that will make them equal. So 3 NO2s, if I put 2 times 3 NO2s, I will make 6 of them. Over here, if I put 3 times the 2 NO2s, I will make 6 of them. And so using coefficients that will make them equal to the same number, like 6 on each side, is the trick. Don't forget to go back and see how that changed everything else. The 2 coefficient means there's also 2 aluminums, so I have to make this a 2 for aluminum. Adding the 3 over here to balance up our nitrates also means we now have 3 coppers, so I need to go and put 3 coppers on the other side. That balances our aluminums and our coppers, and our equation is now balanced. Feel free to watch this video lesson more than once if you feel like you need to. My assignment for you, once you've completed watching, would be to go to page 21 in chapter 3 notes and try all those in there, or at least as many as you can balance. Have an eraser, have a pencil, and give that a try. And stay tuned for lesson 2 tomorrow.